Okay, so let's try the next coding exercise. So open the leetcode.com and go to the problems tab and just scroll down in the search question, search palindrome partition. So the question number, there is a question number 131 and it's come under the medium category. So let's click on it. So let's read the question. A given string s, so we have some string is given. And if you notice in the function itself, the string is being passed. So partition S. So we need to partition the string S. So partition means we need to divide the string, right? In such a way, we need to divide because we can divide in number of ways, right? So maybe we divide in three, like A, B, 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 like we can divide in number of ways. So we need to divide, we need to partition S in such a way that every substring of that partition, every substring of that partition is a palindrome. So what is a palindrome? So palindrome is a string that reads the same forward and backward, which means like uh, if you read from starting to end, or if you read from end to start, then like both are equal. That is called a palindrome. Return all possible palindromes partition of S. Okay, so before even writing the question, let's try to understand the how we are going to approach this, because if we are going to approach, if we know how to solve this now, then to write the code is not a very big task. Anyone can write the code using the for loop, if loop, any number of loops, like anyone can write the code. But to understand, it's the main thing. So given a string s, so we have a string s is given, so we need to partition s, right? So we need to partition s, but we don't know like how we are going to partition. Like we need to partition s because there could be so many possibility to partition, right? So there could be one possibility like a b, right? There could be one possibility double a, there could be one possibility triple a, double a b, right? So there could be so many possibilities. But we need to partition in such a way, if we partition the particular, then every substring, so as an example, so if input is AAB, so if we partition AAB, then each partition, so each substring, A is also a palindrome, A is also a palindrome, and B is also a palindrome. And if we partition first two first and then B separate, then A is a partition, B is a partition. But we can't partition as A and AB. So it means like we can't partition as A and AB, because if we partition like this, uh, then we are violating the what is being asked, because it is mentioned if we partition in such a way that every substring of the partition is a palindrome. So A is a palindrome, but AB is not a palindrome. So this partitioning is wrong. So we can't partition. Partition means we need to cut that particular string, right? So there could be couple of ways to partition. All right, so let's go to the whiteboard. So let's suppose if we have the string AAB. So if we have the string AAB, right? So just focus on this, like where I am moving the cursor. If we have the string AAB, so one approach is we will partition in this way, like where I put the dotted arrow. So one solution is like, okay, let move separate A and then AB. And then one possible solution could be like, one possible means at least one string could be A, right? Just forget about the remaining string, right? So at least one string could be A and the other string could be like anything, or one string could be like of length 2 AA, or one string could be AAB, right? So we need to like what are the possible ways to partition? So if we partition from first, so keep the first string aside, then keep the two string aside. If we partition from first point, or if we partition from the like second point, or if we partition from the third point. Sorry. So there could be like these ways. So let's suppose if we partition from this point, from A, then what are the possibility? A and AB, right? A and AB. But what we want, we need to partition in such a way that every substring of the partition is a palindrome. So if we partition as A and AB, then we are going to check, because we have to check whether every partition is a palindrome or not. So if we partition from A, then string is A and AB. So we will check whether A is a palindrome. Yes, A is a palindrome. Then we will check the AB. So AB is a another substring. Now forget the AAB. Now consider the like as a problem that you have a given string AB. Now you have to partition AB because A is a partition. A is already a partition. A is a partition. A is a palindrome. So we need other palindromes from the string AB. So if we combine, then we can like combine all together. So AB. So as an example, like let's look at the some other example. Then you will going to better understand. So let's suppose there are 10 people in a row. All right. So there are 10 people in a row. One, two, three, and up to 10. Up to 10. So there are 10 people in a row. Now, if I tell you, can you please count the number of people? All right. And you don't know how many people are in the row, but you have to count. So one approach is you will just loop like over this array, and then you are like incrementing the count variable. But if you have to do from the recursion, then what I will do is I will just set to number one, like number one will like told to number two that can you give me the count of all the elements behind you or like including you. If number two will give that count, then number one just have to add just plus one, right? Just plus one. Then number two also don't know. So number two will told to number three, can you give me the count? If number three will give the count, then like two is just going to add plus one. So on. And then when we reach to the number 10, then number 10 will look behind, right? Then number 10 will look behind, but there is nothing behind that. Then number 10, this is the base case. So number 10 will say, okay, I am the only element, so I am going to return one, right? So the number 9 knows how many elements behind him, like total including. So number 9 said, okay, I am the one, so one, and the 10 is giving me the one, so 1 plus 1 2. So a kind of recursion. So generally we solve this like we solve the recursion in such a way there is a one base case, like because otherwise it will be like a non-ending loop. So one there should be one base case, and rest everything is the assumption. Rest everything is the assumption. We are just assuming that the previous element are giving me the output. All right. So the same thing. So this let me erase this. Let me erase this 1 minute. Otherwise it will become very messy. Just a second. Okay. So that's so the in the same way, if if we are looking this question, so what we are doing is, so we are partitioning A. Now A is a palindrome. So A said, I am the palindrome. Now give me the other palindromes. I am just going to merge it. Right. So A said, I am the palindrome. I know I am the palindrome. Can you give me the other palindromes? So how to calculate the other palindromes? So now this is the like this particular thing is another scenario. So now AB is a string. Now we are going to further divide, because if A and AB is a string, then what are the possibility? We will divide from A. Now A said, I am the palindrome. Now you calculate your palindrome and give to me. I am just append myself with you with your result. Right. So A, like, because if you count the number of people in the row, then the number one said, give me the count, give me the number one said to the number two that give me the count of the people standing behind you, right? And then if you give me the count, I am just going to add. I am not going to count the numbers. The same thing A is saying, can you give me the palindrome? So A is informing to AB, can you give me your palindrome substring? If you are giving me your palindrome, then I am going to append A. If you are not giving me, then I am not going to append. Because every substring should be the palindrome. If AB did not return any output, then this A said, I am not going to merge with you. If you will give me some output, then I am going to merge with you. So now solution is AB. So if let's suppose if you have given a string AB and you need to partition AB in such a way, so one partition is A. So you will partition from so A A is this and B is this. So now A will check. Then we will check if A is the palindrome. Yes, A is the palindrome. So now A said, I am the palindrome, and A will inform B. Can you give me all the palindrome partitioning, right? And if you return me the output, I am just going to merge. Then there is a B string. So for the B, then we are again going to partition B. So we will check. Okay, B is the like uh, one B is the palindrome. Then B is going to ask this null string, because after that B there is nothing. Then B is going to ask that if you don't have anything, can you give me the output? Then this is going to return to the B. Then B is going to merge. So this will be the output. Then once the B is generated, then B is going giving the output to the A, because A said, I am the output. If you are the I am the palindrome. If you think you are the palindrome, give me the output. I am just going to merge. So A said, I am merging with B. Now we know A is the palindrome. So this A is the palindrome. Now this A said, I know I am the palindrome. If this sub array returning me something, and that is returning me something, then I am going to merge. So then A is merging with the output of this. Then A merge itself. So one output is AAB, right? So that's why one output is AAB, right? Similarly, other way. So AAB. So now because we divide from first part only, but now we have to divide from the second part. So now the second part. Now we will check if we are dividing from the second part, we then at least in a partition there is a AA, and we will check the other thing if the first is the palindrome, because if the first is not a palindrome, then there is nothing, like there is no way to check further, because every substring should be the palindrome, because if one is not the palindrome, then why should we check further? Then we will check whether A is the palindrome. Yes, A is the palindrome. Then A will said, AA said to B, AA said, I am the palindrome, give me your output, right? So A said, I am the palindrome, give me your output. So B will return their output, B will calculate their end. So basically the same function is going to call again. B will calculate their output. Then whatever the output B is giving, then A is just going to append it, right? A is just going to append it into the same list. So now the third scenario, AAB. Now we are partitioning from the AAB. So after that there is a null, all right? So AAB. So now AAB set, then we will check whether the AAB is the palindrome. If AAB is not the palindrome, then we are not going to check further. But let's suppose if AAB is the palindrome, then we will set this null string. Can you give me the output? Whatever the output, this null string given to this, then it is going to append. But right now AAB is not a palindrome, so we are not even going to check the further. So the same thing we will like apply into our logic. So let's see how we are going to. So if you see the output, our output is a list of list. So basically we need one list, and then we are going to append the further list. So we need one list. So let's take the list partitions. Partition spelling is wrong. Partitions. So this should be our output, right? Okay, which is perfectly fine. Now first we have to divide from first part. Then like when we divide from the first part, then it may or it may not give me the one output. Then we can divide from the second part, then it may or it may not give me the output. Then we divide from the third part, it may or it may not give me the output, and whatever all the output will be given, we will going to append in one array, right? So how you are going to divide, like from the first, from the second, from the third? Just a for loop. Once the I is equal to 0, I is equal to 1, I is equal to 2, just a for loop. So the same thing we are going to for I in range of length of s till s. Okay, so first we are going to, because so first I is 0, so first we need to check, but first we need to partition this. 1 minute. There is a very markers. So we are going to check first. Okay, so let me wipe these things. Okay, yeah, fine. So now we are going to check this a. So how you are getting this a? So if I is 0, then how you are getting this, like this string only, because focus on this string. We are not going to focus on the remaining string, because then when I is like when the pointer is here, then how you are getting this string? So how you are getting the prefix? So prefix is s of I plus 1, because I is 0 and we need to till 1. So because 1 is not included, this is the 0 index, this is the 1 index, because basically like a subset of string. I believe you are like, you know how to get the subset. So this is giving me the a. When I is 0, this will give me the a. When I is 1, this is giving me the a. When I is 2, this is giving me the aab. So now we will get the prefix. So if we get the prefix, right? If we get the prefix, then what next? First, we have to check whether the prefix is the palindrome or not. Because if prefix is not the palindrome, then I am not going to check further. But if prefix is the palindrome, then prefix will tell its suffix, give me your output, and I am just going to append with them. So we have to check if is palindrome prefix. So whether the prefix is a palindrome or not. So we have to write this function. So def is palindrome and it is going to get the prefix. So we know how to check the like the palindrome. So if string equal to prefix of, so if we reverse the string and that string is equal to the original string, if it is equal, then it is going to return true. If it is not equal, then it is okay. If it is palindrome, if prefix is palindrome, then we are going to check further. So now our sub problem is this, right? So our sub problem is this. So what we have to do? So our sub problem will give some output. Will give some output. So it will give some output, and we don't need to calculate this our sub problem, but because we know how to calculate this. So we should not calculate, because if s is equal to ab, then we are calling the same function. Then we are going to call the same function, self dot partition. But this time string will be s of I plus 1 till end. I plus 1 means like 0 plus 1 means 1 and 1 to till end. Now we are passing a plus b to this partition. Then it will check again. Then it will check again. Then it will check again till the end. So there will be one stage, because now a is equal to ab. Okay. Now string is ab. It will reach here, which is perfectly okay. Now again we are partitioning with a and ab. Uh, 1 second. Then we are going to check like this partition a and ab. So this partitioning a and ab. So now a, then we will check. So prefix a. So now we are going to check whether the like prefix is palindrome. Yes, prefix is palindrome. Then we are calling our function. If it is palindrome, then we are going to call. Then we are calling the function with the b. Then the string is b, which is perfectly fine. Okay, then it will come. So then we are again going to partition b, right? So now we are again going to partition b. So we will check b, whether b is palindrome. Yes, b is palindrome. Then we are again going to call. So now we are calling this. We are calling this, right? But there is nothing like how you are going to partition, because like there is zero length. So how you are going to partition? So this is our base case. This is our base case. So we have to write our base case. So if s is equal to blank, all right, then what we have to return? So if you see the output, we have to return list of list. All right. So what we have to return? List of list. All right. So you can call it as a suffix partitions. All right. So you have just noticed with this approach, now with the like a recursive approach, this problem is looks very simple. Like otherwise it may or may it not be like complicated, but using the recursive problem, it looks very simple, because we said if a is the palindrome, just give me your output, I am going to merge. So now self dot partition will give their output. So their output is this. So first output is this. So this here we will get this output, a list of list. So this list of list. All right. Now this list of list will go to the B. Now B has to attach with that, and it should be like this. So list of list. So it should be like this. Let me better I'm unable to like draw here. Let me better type here. So it is giving like this. Empty will return like this. So if empty will return like this, now empty is going to, so this is going to give the output to the B, because B said I am the palindrome, give me your output and I am going to merge. So how is B going to merge? So if you said, so B is a prefix, but B is a prefix, but we need to attach the string, because list plus list is equal to list, because we need the output as a list. If you say list plus suffix partition, but suffix partition is like this only, right? Then we are getting some other output. Then we will get this output B, and then we are going to get this. Then we are going to get this. All right. But we don't need this thing. So what we can do is, whatever the output is, we are going to run a loop on this, and we will get the first element. So what we will do, so let's remove this, because we have to attach the B inside. So what we'll do for partitioning suffix partition, right? All right. So whatever the partition will be given, we are going to append that in the output. Append. And what we have to append? We have to append B. So we have to append B. B means prefix, and whatever the output given by the suffix. So whatever the output given by the suffix, partition, that's it. And we are going to return the partition. So when B is going to attach with empty list, then it will become only this thing. Then this output is going to this A, then it will become this thing. Then this output will go to this, then it will become this thing. Right? And we are going to append this partition into the partitions array, and we are going to return the same thing. We are do with because we are running a for loop, because first I is 0, then we get one output. Then I is 1, then our prefix is this. Then I is 2, our prefix is this. And because this is not a palindrome, so we are not even going further. So let's try to run it. So our solution has been accepted, so let's try to submit it. So our solution is accepted. I know it is taking, we are beating only 11% or 12% of the people, and we are not taking any memory. So in memory perspective, maybe a little bit memory because of recursion, but memory perspective we are good, because recursion is calling a lot of function again and again and again. So that's why the time complexity a little bit higher, but all the solutions are accepted, or the test cases are accepted, and this is the one of the easiest approach, which I think is easy, which I found is easy. So you can also try this question, and if you think from the recursion perspective, and recursion is a very easy topic. You might think recursion is very tough, right? But if you just think about that example which I gave you, let's suppose there are 10 people in the list, and you need to count, but you need to count via the recursion. So how you are going to do the recursion? So you will tell the first people, can you give me the count of the remaining people? So whatever the count it will give, but you get, you are just going to add +1. Then second people will tell, can you give me the count of the remaining people? Whatever the count you will give, I am just going to tell. So this loop will keep going on, recursion will keep going on, and it will reach to till end. So the last people said, okay, there is nothing behind me. That is the base case. So the base case you should know. Rest you should not. You don't need to worry. So the base case. So these things we should know. If the string is empty, we need to return list of list, and that we already know because we need to return the list of list. So we are returning the list of list. That's it. Otherwise we are not doing anything. We are just doing this, okay, because we know we have to do the partition, and we know because there will be a couple of ways to do the partition. We will partition from the first point, we will partition from the second point, we will partition from the third point, a couple of way. So for that we are running some loop. But if we partition from the first point, further there could be a number of partitions, then for the further we are not going to taken care of. We will just, because we have to see each substring should be the palindrome. So if we are partitioning from the first hand, so one substring is a, one substring is a, one substring is a b. But if first is the palindrome, then only we are going to check. Then how we are going to check? We are not going to even calculate, we are just passing into the same function, and that function is going to calculate, and whatever the output it will give, whatever the output it will give, I am just appending with my prefix. I am just appending with my prefix. That is the list plus list, because this is going to list, this is giving me the list, and I am going to append with that prefix. That's it. So you can also try this question, and thank you.